So we're going to start looking at breathing mechanisms, so what actually is happening inside of your lungs. Breathing is also called ventilation, so where the movement of air into your lungs and then out of your lungs. Inspiration, in, it's bringing air into your lungs. Expiration is when air leaves your lungs. There's an inspiration, volume, amount of air, and an expiration. So actual process, inspiration, it's regulated by atmospheric pressure. So atmospheric pressure is the force that moves air into the lungs. So we don't notice the weight of the air. Air is actually like 28 pounds per square inch. Our body has pressure and pushes back, so we don't really notice that pressure, but it is fairly heavy. So when the pressure on the inside of the lungs decreases, that atmospheric air is going to get pushed in. So lower pressure inside, higher pressure outside pushes air into the volumes, into the lungs. Air pressure inside the lungs is decreased by increasing the size of it. So what happens is, how can you think of this? If I have this much air and I put it into a bigger spot, what happens? Higher pressure or lower? Lower, because there's more room for the air to move around. There's not as much pressure. So when my lungs open up, so think about everybody right now, take a big deep breath, bring air in. What happens to your chest cavity? It goes out, it expands, it gets bigger. So when my lungs spread out, it creates lower volume inside or lower pressure, and that's what brings the air in. If you breathe out as hard as you can actually almost feel your lungs collapsing or squeezing closer together. So when air is coming in, and if you're taking your test, you can think about this. Take a big breath, my chest area gets bigger, creates less pressure inside, air moves in. Surface tension between your pleural areas of the lungs follow the chest wall, and they're going to expand. Muscles involved in expanding are your diaphragm, that separates basically your thoracic cavity and abdominal cavity. And then your external intercostal muscles, those are the ones that are in your ribs. Inspiration, the diaphragm contracts and moves down. So if my diaphragm moves down, there again, it's giving more area in my thoracic cavity. The external intercostal muscles contract. That moves the ribs and sternum upward, and you can feel that when you breathe. So it's going to move the ribs and sternum upward and outward, also creating larger area. Larger area, lower pressure. So that thoracic cavity enlarges, the lungs expand, and then that alveolar volume increases, causing your pressure to decrease. I don't expect you to memorize the to part, but it allows the pressure to decrease, and then atmospheric pressure pushes air in. As your lungs expand, a surfactant keeps the alveoli from sticking to each other. So basically your alveoli are lubricated, so when they do expand and get very close together, they don't stick together, because you don't want that to happen, because then they would collapse. So the surfactant is basically like a lubricant, so those alveoli don't stick to each other. They don't collapse when that air pressure is too low. When you take a deep breath, the diaphragm and intercostal muscles contract forcefully. Also, a little bit of your pectoralis minor in your chest, sternocleidomastoid, and scalene muscles help to pull the rib cage up more. The main ones, though, are your intercostal muscles and your diaphragm. So here, if you kind of look at a picture, we're not talking big numbers. So here, my inside air pressure is 760. My outside air pressure is 760. There would not be much of an exchange because they're equal. So when I inhale, diaphragm comes out, ribs come out, my lungs expand, it goes down to 758. So it is only a difference of 2. That's not very big. However, it's just enough that that higher pressure outside is going to bring air into your lungs. And here is just a side view. So then expiration, so when you breathe out and everything kind of squeezes back together, forces of expiration, elastic recoil of actual lung tissue, and then the muscle tissues are also going to recoil or expand from that surface tension, and then normal expiration is passive. When you breathe, you don't really think about it. You know, you don't feel huge movements in your chest cavity. However, if you when you go to the doctor's office and they say take a deep breath, you can really feel that. And if I asked you to blow all the air you could out of your lungs, you would actually feel that in your chest. Normal respiration is passive. You don't notice it as much. So now the muscles relax. Your diaphragm relaxes, it's going to come back up. Your intercostal muscles are going to relax, and it's going to kind of let your ribs come back in or down. That decreases the volume, so it makes your lungs smaller, which creates a higher pressure. Increased tension of the alveoli then decrease their volume also. So it's not just your lungs, it's the little alveoli that are inside of them. When that pressure increases to about 1 millimeter mercury above atmospheric pressure, air comes out. So here again we're looking at small numbers. Forced expiration, so if you are really trying to breathe out all of your air, intercostal muscles are going to still help, along with, you actually feel it. If you right now do blow all of the air out of your lungs as much as you can, and you should actually feel it in your abdomen, because those ab muscles actually help to push the air out of your mouth. You can feel your lungs, you can almost feel them getting smaller, but it's actually not a bad ab workout. So relaxation, the diaphragm, like I said, is going to move up. These muscles are relaxing, so everything's kind of moving downward again, making that area smaller, and then that's going to push the air out. So next part that we look at is going to have different types of volumes that you have in your lungs. And I think I'll stop and take a short break, because when we get to this, there's a lot of different information that you'll need to know.